This is a tutorial for the pfmap macro for ArcGIS that has been developed. This tutorial will focus on the interpolation and the mapping function of this macro. Whenever that you run this MXT file, which is called precision farming, from the program or outside the GIS module, you will have the ArcGIS software started, and pfmap window pop up as the first screen. To start the interpolation process, you just simply click on the interpolation, and then you can continue with the application map. Before we start the interpolation, I want to talk about the path that we are using in this program. First path that we are using is the database folder. Mostly we use the boundaries folder inside the C drive. Inside the boundaries folder, we have the plots that contain the shapefile of the whole plot, and also the seasons. Inside the season, we have got all the data that we have been gathering, and then also the data that will be produced by the program and will be saved in the database. And here you can see the seasons and the year. Inside each season and the year, you can see soil and all the elements that inside. You can create interpolation surface for any of these elements. You can simply go to EC, for example, and point. You can see the data. Each data file that we use in this program, which is ArcGIS data, is called shapefile. The shape files are coming in the line and polygon and point format. Mostly we use the point format of the data. The important thing is that every file or every shape file which is finishes by SHP is consisted of not just one file but 6 or 7 files that hold the information, the other information that consisted and are appropriate for the mapping and also projection and all the other information that you needed. So this is about the database folder, and also we have another folder inside the C drive, which is workspace. Inside the workspace, we save all the temporary files that the program will create, but we'll show you later. So we just click on the interpolation. The first wizard is the program asks you to give you the boundary database, the one that we were discussing. So we just simply go to database folder and click on boundaries and click select. So the program will create a list of the folders that is inside the boundaries folder. And here it's important to click on the right plot number that you're going to create data for. So then when you continue with the interpolation, you can be reminded with the right number of the plot to provide the information for the program. So let's say I want to create information for the plot 3117, and just click on that and click OK. The next step is that the program asks you to provide it the workspace folder. We just click on workspace and click and select. You notice that it's still in the drive C. You can read the message from the top of this window. Just simply click and select, and here is the main wizard for the interpolation wizard. We have 3 steps in this interpolation, but one of them is already done. which is the cell size. We'll talk about it later. So we just have to give a name for our project. So we can just simply give test as a name, and then since we are creating a raster data or a surface based on our raw data, we should have a name for that. For example, I can give test EC for the data that I'm creating surface for. So this name will be used to save the final output of this wizard. By clicking on the create project, a folder will be created inside the workspace. As you can see here, inside the workspace C, a folder has been created. The folder is empty at this time, but it will be filled with the data later. Then the next important step is to provide the raw data or the shape file of the point that we've been talking before. So we just click on add point. We go to the database folder, to the boundaries. We are reminded that we are providing the data for this boundary, so we just go to this folder, and then we go to the seasons, whatever season that we want, and then we click on the whatever information that is inside the database, provided the data is available and it's there. So we go to desired element and then point data, and we just click on that. This is the shapefile that we've been talking about. Inside the ArcGIS program, the shapefile are just shown by just one file, but it's important for you to remember that this file is not just one file, it's consisted of 6 or 7 files. And then the icon also here shows that this is a point data, which is suitable for our interpolation. Just click on add. Another point is important, that inside this point file we should have enough data to create the interpolation. As you can see, if I click on add, the data has been added here. I can see the points. I can go to the attribute table, and then you can see all of these point coordinates and their value for EC. And you can check on any of them will be green, and you can certainly see their values, examine them. You can check even their statistics. You can just right click on that on the bottom of it. You can see some statistics here and so on. So the data is added. We have enough data, more than 10 data, so we're good at this point. So next step is to give the software which column is for interpolation. As you can see, we have many columns here. These are the columns from this attribute data. You can see here there's a list of them. So it's important for the program to know which column is actually contains the data that are going to be used for the interpolation. We just click on EC, and this second part is done. You can see has been gray, it's been green. The third part, which is the cell size, we just give the default one, which is the 1 meter square, because our system of projection is based on meters. Whatever unit that we are using is meters. You can see here your units, and then also you can see the coordinates based on the Kartao Malaysian meters. If you cannot see these meters here, you can go to the layers and go to properties, and just change here the coordinate system that you are using. Just check it, and then make sure that it is in this coordinate system as we shown in the tutorial. So this number is important for you to remember, that if it is small, it will be computer and time consuming. It's means that if this value is smaller or has decimal or something like that, it will take more time to create the surface, and you should consider the power of your computer that you're using that. So for example, for this for this example, I just can give a pixel size of 1, or just make it, I can make it 3 or 4 or whatever that I need. So we're done here. All the names are given, and then these are the checkpoints for you to just double make sure that everything is alright, and you can just click on run triggering and continue with the next step. The next step is important, and then we try to put it as separate from the wizard, is that we need to have a boundary for the interpolation. Let's just give the boundary plot. I go to the database folder and go to the boundaries. I go to the plot. Instead of going to season, I go to plot, and then I just click on the shapefile of the region. This is the region that I'm going to create a interpolation surface for that. You can see these are also shapefiles, but the icon is different. This is the polygon shapefile. We just click and select. Make sure that the database plot number and also your shapefile number are the same, and just click and select, and the computer will start doing all the calculations. And then also it adds this boundary of the region to the system. You can see that this the surface has been created, and you can just click on the yes or no before you want to terminate the interpolation, or just go to mapping. But before we go further, I want to show you that why we need to give the boundary of the region. You can see that the interpolation has been created. This is the interpolation. This is the integer interpolation has been created. Before that, the program has created the floated integer, and because the floated integer is not acceptable for the mapping section, we just converted it automatically to integer raster. If you want to read about it, just go to the help system, and then here another layer is our point data. We just give it to the program, and here we have the boundary, and this boundary is needed to give the coordinates, exact coordinates of the XY coordinates of the region. Without this boundary, the program will just create a raster based on the point parameters. Okay, now we're done with the interpolation. This prompt gives notices that this is you have a raster interpolated data in this path. If I go to the workspace, you can see inside the test I have, which was the empty. Now I have data inside. You can see that these are the data associated with my raster data. This is my integer raster that will be used for the mapping. This is floating. This is just this is unusable data, and these are the folders associated with these raster datas. So we just click on yes, and then we go to the application map. Alright, at this point we need to again ensure that we have the same boundary. You see everywhere we have the same plot number, so this is this reaffirming that we are having the same boundary. And then again we need to specify the workspace for the mapping section. We just give this workspace folder, and we just click on add, and then this is the wizard. Okay, this is the wizard for the mapping. It has two tags. One is NPK based on EC, you can create a map or application of NP and K based just on EC data. That be EC data means the raster data we've just created, or we can go and create other elements. If let's say I want to have a set of soil sampling data based on N, NP, and K, I want to create a application map based on this data. So we just go first for the NPK based EC mapping. As usual, we just need to give a name for the project and then final map name. This is the application, this is the final product of the program. So we just give whatever name that we want, and then it is crucial that we just click on create. See these two indicators, and then another folder has been created in the workspace folder, NPK EC based test. This test comes from the name that I've given, and then this is just to ensure that this is from this section of the programming. You can see that because we are coming from the interpolation, the path to the interpolation service that we have created is there. If it's not there, you just simply click on this icon and then go and give the right raster pass to the program. The third part, which is very important, we still need a divider polygon for the mapping section. We just need to go to the same path that we have been there, boundaries, then this one, and then flood. You can see there's two shapefiles. We use this shapefile for the interpolation, and then we use this shapefile, which is a divider, has TD or divider at the end, for the split polygon. A split is one section of the mapping, and it's needed to refine the area of all of the zones. So just click on that and we select it. This is also important to give the right field name, because the computer doesn't know which of the fields are there for the split field, and that's it. We need to specify the split field field name, and then you can see that we are done here. You can go to the advanced section and change the form. These are the formulas that are used for calculating NP and K for data. You can change this formula if you want. You can just change. This is the warning that if you change it, you can change it, but you should be careful about that. And so these formulas are pretty much simple. Those are based on two variables. First is the area of the region, and then the amount of EC. So based on these two, we can calculate the NP and K. And if this is the label, you're safe not to manipulate this one. But if you do want to change it, you can always look at this default section and do it. If you do change what you want to change it, you can just click on restore default, and then that's it. So we're done here, and then we just click on run project, and then you can see that this is the progress report. It gives you the section that the program is using right now. Because we give a 3 meter pixel size for our raster, the program now is running fast, and it's creating the map smoothly. You can see that the map has been refined. Now the plot the plot area is done, and then now is a formula is added, and the plot has been labeled for the amount that is needed for the fertilizer application. And at the end, you can see this plot. Every zone has got one the label of the amount of urea, phosphate, and potash that we need to apply. And this is the statistics that actually for the statistic for the whole area. For example, if I want to know how much nitrogen or urea I want to add to the field, just go here and then I can see the mean or the sum or the cumulative kilogram of any element. We have three statistics for N, P, and K. We have mean, sum, and range for N, mean, sum, and range for P. And the final step is that because this is the unstandard or the informal name for the map that I gave, I just want to create a standard name for that, just like the one that we have just discussed. We can go ahead and then click yes, and again we need to give the database location, and it gives us this wizard. This wizard will ask some information from you and then generate a file name, and then it changes the file name, the file name of the final map, application map that you've created. You can see again a list of the database. Then whatever I create, I just created application map, and then I have yes, of course, is soil application map, and you can go for other elements. And then because it comes from the EC, we just click on electrical conductivity, and then we just click on we can change it to 7, and here is the file format. Because the file format is just a shape file, we just leave it there. And then if I click on OK, the file name, which is the test1, and then it's been saved in this folder, it will be changed to a combination of these fields. But before I do that, I just show you the final product. This inside this one, we have a lot of files that have been created. These are the temporary files, the files that have been created by the program to create the final map. And then you can see that this is the one file, which is the shape file, and test1, that this is the final data that has been created by the program. And then this is the statistics for this file, which is this one. And if I click on OK in this wizard, the file name here will be changed. So let's do that. Just click on OK, and you can see that this file name has been changed to correct and standard name.